Well, folks, I have 12:30 or so we'll get started. Thank you for coming along. Appreciate your participation in our Nerd Coffee online workshop. As I said in the invitations, all of these sessions have been awarded half an hour of Category 1 credits, both State of Maine and SAF. As we go through the day or through the presentation here, if you have a question or a comment, use the chat feature at the bottom of your screen. At the end of Tony's presentation, I will try to moderate through those as we have time. There are 2 more upcoming sessions that I have scheduled for the month of December, so stay tuned for those notices as I get things finalized. And make sure when your name shows up on today's presentation that your name and email actually are there. If not, please send Cindy Pascal an email letting her know that you were here with your email address so that she can send you the certificate. Cindy will post post your email and a note on the chat as well. So please pay attention to that and make sure that we have all your information so we can get you the appropriate certificate. So with that, Tony, the floor is yours.
Great, thank you, Ray. Can see my slide okay?
Yes, sir.
Great, thank you. Well, good afternoon, everyone. Thanks for joining us, and thanks to Ray for setting this session up. I really appreciate that. And I just want to provide an overview of forest technology, sort of the current state of forest technology as I see it, and that obviously tends to be through the lens of geospatial science and technology.
Nerd Coffee webinar
someone is talking. If they could mute, please.
Okay. Can I give you a call at 1? Okay. So cool. Thanks. Bye.
So many of you know who I am, Tony Guay with the Wheatland Geospatial Lab. I'm a remote sensing specialist. I also support teaching and research in the School of Forest Resources, and then of course do a lot of outreach, training, and support with our external stakeholders and partners such as yourselves. So there's 3 categories of forest technology that I'd like to focus on this afternoon.
Hi.
David Wilcox, please mute your.
Actually, bring it over here.
Thank you. So there's 3 technologies or sort of categories that I'd like to focus on this afternoon. Data and intelligent information, again, from sort of a geospatial science and technology lens or perspective. Strategic and operational tools, and then autonomous technology. So starting with intelligent information and data, there's a lot of advancements these days with enterprise GIS and communicating real-time data and information with GIS dashboards, for example. So I'll mention a little bit about that technology. Geospatial cloud computing and just cloud computing in general is really the direction that things are headed quite rapidly. Even just a few years ago, cloud computing was used, but not to the degree that it is today, and that trend is just accelerating. Big data is a primary driver of cloud computing resources, so we'll talk about that. And then satellite-based Wi-Fi. So enterprise GIS, really you can think of it as the whole structure of GIS, not just on your desktop, but everything is in the cloud, right? And geospatial cloud computing is optimized for spatial data and information. So it's really everything that you can do in a GIS, but in a cloud environment. And that's really where a lot of this technology is headed, again, from a GIS perspective. you know, what a crazy year it's been. I'm sure many, if not all of you, have seen the COVID-19 GIS dashboard from Johns Hopkins University. So this thing is updated, you know, every day, probably multiple times a day from, you know, a number of different data sources and data streams. And that information is all available in real time or near real time. The other thing about Enterprise GIS is you've got just broad integration across your organization. And that's a key characteristic of Enterprise GIS. GIS dashboards have become very popular. I'm sure many of you have seen them or use them in your work or in your organization. FIA is Forest Inventory and Analysis. They do a lot with GIS dashboards. The one in the upper right of your screen is from the Forest FIA Forest Pest GIS data dashboard, and I believe that's Hemlock Woolly Adelgid. So just some real-time data, again, from their data streams showing you current extent of Hemlock Woolly Adelgid. You know, harvest operations GIS dashboards like the one on the left are very common. And again, Enterprise GIS feeds data into these applications, and then you know, you as a user are able to see that data in real time. The link on the bottom, the one on the right bottom of your screen, is from a YouTube video sponsored by ESRI for this week was World GIS Day. And this, I believe, was actually a talk that J.D. Irving gave at one of the ESRI user conferences in San Diego. They do that every year. I think a couple of years ago, they were one of the main presenters. Definitely check that out if you're interested. You can just Google it, or the link is there on the screen. But they've just got that really tight integration of Enterprise GIS. They use a lot of different dashboards. This is an example of one of their forest operations transportation dashboards. So geospatial cloud computing, again, is just this infrastructure of cloud resources that are scalable, available over an internet connection. Obviously, a high-speed internet connection is preferable. And it really allows you to support and leverage big data. We hear a lot about big data these days, and that trend also is continuing. Not just in, you know, geospatial science and technology or forestry, for example, but really in, you know, any kind of industry that you could imagine. It's really a cross-cutting technology, much like GIS is. The term elastic cloud computing is often used as one of the key advantages to cloud computing and big data design and support. And that's just where, you know, you've got really the full resources of the internet, so to speak, to leverage for computational tasks, data delivery, data visualization, you know, all those sorts of technologies and activities that you would use with GIS data, among others. Software as a service is a term that's used within the cloud computing environment. And then desktop as a service, where you don't have a high-end workstation on your desk, but you're able to, you know, log into a website in a cloud service and leverage, you know, very powerful desktop-like computing environments directly over the internet. So that's a trend also that's accelerating, especially with, you know, we're working with so much data these days, truly big data. LiDAR data is a good example, but it's certainly not the only example. And these technologies require a lot of computing horsepower. WebGIS is another term that's commonly used. And then communicating results from these types of cloud computing analyses is commonly done these days with things like GIS story maps and dashboards, as I've already mentioned. And it all kind of leads to the concept of open data, where, just a lot of data is available and often freely available through cloud computing environments. FIA is working on their big map. This is sort of their first effort, or one of their first efforts at moving to an enterprise GIS environment and being able to serve up all of their FIA data, historical data, maps, all of their map products within a cloud environment. So that's pretty exciting. I'm not sure exactly when this is going to be available for public consumption, but I believe it is early to mid 2021 where this will be available. ArcGIS Living Atlas is another example. Just lots and lots of data that are, authoritatively sourced and available through ArcGIS Online and other web map services. So you could just Google this to learn more about it. But they've got everything in there: Sentinel imagery, Landsat imagery, all sorts of derivative products, hill shades, terrain maps, NAPE imagery. So really an impressive set of imagery, and you literally just link to that web map and you can pull it up in your GIS and work with those data on the fly. So again, another example of cloud computing and geospatial cloud computing specifically. Something that is emerging, it's still very much in the development phase, but satellite-based Wi-Fi. As all of you know, or many of you know, working in remote locations, you don't have an internet connection. Often you don't have a cell phone connection. This is a technology that seeks to break through that limitation with a full constellation of low Earth orbit satellites, providing full internet access with some decent speeds and low latency. SpaceX Starlink is sort of the leader of the pack these days. And they've got satellites up there now, about 800. They're going to have beta testing and open to public subscriptions by early 2021 in lower Canada and of course this area, northern US. So that's pretty exciting. Their full constellation is planned for 12,000 satellites. Currently, this technology, you could think of it as kind of in the early days of GPS, where you had some satellite availability. You could use GPS, but sometimes middle of the night, depending on your area and where the satellites were. That's kind of how this is right now. But there's a lot of R&D behind this and a lot of interest in this type of capability. So I expect this to be moving at an accelerated pace over the next few years. In terms of operational tools, again, from mostly a GIS, geospatial science and technology perspective, I want to talk a little bit about LiDAR, of course, but just kind of hit the highlights. And then I want to talk a little bit about artificial intelligence and machine learning concepts. So first order LiDAR derivatives, things like bare earth terrain models, canopy height models, terrain indices like slope and aspect, even your hill shades, those sorts of things. Many of you, I'm sure, are using these types of data products already, and they're really powerful, especially from an operational perspective. Laying out harvests, just being able to see the ground, the terrain surface with a very high level of detail is really been a game changer in many perspectives. Enhanced forest inventory, where you take the LiDAR point cloud and you develop relationships with calibration plots where you measure traditional field inventory parameters. That's something that's commonly done these days and has been for many years. We've done some of that work with Seven Islands and more recently with Bascahegan. And that work continues through a CFRU funded project that we're currently working on with a goal of developing EFI best practices for Maine. So a little bit about the CFRU project. Really, we're evaluating LiDAR metrics and models for consistently and accurately mapping EFI over large forest areas, specifically in Maine. And we're really looking at comparisons of plot layout and stratification strategies, different measurement requirements, so variable versus fixed radius plots, the quality and type of calibration plot data, so the inventory plots, how they're located, precision GPS versus recreation grade GPS, and then LiDAR density to the degree that we can, and type of LiDAR collection, so leaf on versus leaf off. And we're doing this in a number of different sites in central and northern Maine, and also in New Brunswick, with help from our partners in the Canadian Forest Service in New Brunswick. So the goal of this project ultimately will be, a series of map and data products that illustrate some of the best results possible and some of the challenges involved as well. And then a best practices guide for Maine from a perspective of VFI, and then workshops, of course, to help folks understand and use these types of data. JEDI Forest is a newly funded project with the Wheatland Lab and the Center for Research on Sustainable Forests, just recently announced. This will be using the JEDI mission, which is a spaceborne LiDAR on the International Space Station. And this is going to be used to model forest carbon from essentially LiDAR point clouds measured from space. So that's an exciting new project on the horizon. In terms of artificial intelligence and machine learning, this is something that is just growing very rapidly. You can think of the US and China as sort of the leaders in this research and development currently. And there's just a ton of money that's going towards R&D for AI and machine learning. Machine learning at its simplest level, is just a subset of artificial intelligence. Stuff that we all commonly do these days. Random forest is a very good example of a basic machine learning tool. Support vector machines would be another example. But you just got these large data sets, and you throw everything into it, and it will tell you the input parameters or variables that are most important for predicting your outputs. So those are used often for EFI mapping, for example. Deep learning is much more sophisticated and looks at broader AI concepts, and it will really take unstructured data from a variety of data sources and data types and formats. We'll analyze those and attempt to solve new problems. And most deep learning algorithms use artificial neural networks that mimic the way the human brain works on a problem to make sense of some pattern or interpret some pattern in the data. So that's really, very broadly the concept of AI. One of the key challenges and struggles with AI currently is just the massive amount of data that is needed to train the model to then produce a result or an output. So that is a challenge. Cloud computing helps address that, and desktop as a service, where you've got really high-end computing power available through a cloud computing environment. But it remains a challenge with current AI technology, where you've just got to train, tens to hundreds of thousands of training examples to have an accurate prediction. Want to spend a little bit of time talking about autonomous technology. So sensor networks and satellite-based Wi-Fi, I think, is really going to open up a lot of new possibilities with automated or autonomous sensor networks. Of course, drones, we use those in the Wheatland Lab quite often, so I want to kind of give a brief update of some of that technology and the state of that technology. And then, of course, autonomous vehicles and equipment, I'll touch on that as we wrap things up. So sensor networks, they've certainly been around for many years and definitely used a lot in research. However, some challenges there with, just storing the data, keeping batteries charged, those sorts of things. Newer technology to keep batteries charged, better batteries to store the data over longer periods of time under difficult conditions. Those are all improvements that are constantly being made. And then just transferring the data, satellite-based Wi-Fi, I think, is going to offer really a game-changing technology shift for automated autonomous sensor networks, where truly they can be autonomous for much longer periods of time. So I think there'll be a lot of new activity in this area. So obviously for remote monitoring, these types of networks are important. Wildfire detection, they're used for that. Road washout detection, monitoring culvert conditions. Certainly forest health and agriculture are definitely big users of autonomous sensor networks. In terms of unoccupied aerial systems, there's sort of the general two categories: fixed wings drones and then rotor-based drones. The Part 107 rules from the FAA remain a challenge, and of course the biggest one that especially those of us in forestry are most concerned with are the line of sight requirements with UAV technology. A game-changing technology that is going to help solve that issue is something called ADS-B, Automated Detection Surveillance Broadcast. And this is really part of the next generation of FAA's air transportation system, so the sort of the national air transportation system. And this allows pilots the ability to have greater situational awareness because this system, this automated system, allows pilots in manned aircraft to know where other aircraft are and, importantly, where UAVs are. So UAVs will broadcast this system, all planes broadcast this system, and it just increases that level of awareness and safety. And this is going to lead to a concept that's talked about a lot these days in the literature of drone highways. And some companies like UPS and Amazon are already testing beyond line of sight UAV with this concept of drone highways. So I think that once this is fully implemented, that's something that will really help open up UAS work, particularly in forested environments. Another big R&D effort and just a ton of progress that's happening is with autonomous vehicles. Automated driving systems are developing very rapidly, and some of this technology has been around for quite a while, like lane assist, in new vehicles, adaptive cruise control, those sorts of things. And those types of things will continue to be developed and refined over the next several years. And currently, the state of the R&D is at about 2025, and certainly beyond. Fully autonomous driving is going to be a reality. There are a lot of benefits. Certainly, there are some challenges and a lot of concerns. But in terms of safety, it's much safer. Just you look at the statistics. Insurance companies have already done the homework on this. Hands down, much safer. That definitely economic benefits to this, societal benefits, much fewer accidents. Highway accidents are just huge toll in terms of the economic and just human cost involved from a year-to-year basis. So lowering those issues very greatly over the next few years. Efficiency and convenience, mobility for those that are disabled. A lot of advantages there. All the autonomous technology with specific to vehicles really relies on big data, artificial intelligence, and 5G network capabilities. Satellite Wi-Fi is also going to play an important role in this. There's a lot of companies working on this technology. Probably the top 3 players there are Waymo, Cruise, and of course Tesla. What else? Well, there's tons, right? There's a lot. You know, the sort of the category of technology is very broad. But again, more specifically to forests and forestry and geospatial science and technology, you now have LiDAR on your phone. The new iPhones have a LiDAR scanner in them, or a LiDAR machine, and you can measure in real time and build these 3-dimensional models directly from your phone. So, you know, sort of turnkey handheld LiDAR recording devices are going to become much more common over the next few years, and we're already starting to see that. Microsatellites, where you've got very high repeat times for collecting data at any one location on the surface of the Earth, with very high resolution, spatial resolution, radiometric resolution, just really high data quality, is something that is common and becoming more common. Planet Labs on your lower right image is an example from Planet Labs. So they've got a whole constellation of microsatellites. Hyperspectral imaging is something that's still experimental, much like multispectral LiDAR, but that work continues, that R&D continues, and there's a lot of advantages there, specifically with hyperspectral imaging, just being able to discriminate among different forest types and vegetation types with a much greater level of detail and specificity is something that holds a lot of promise. And then beyond that, more broadly, there's just the concept of data fusion, where you take a number of different types of data and try to take the best from each one of those technologies and work with them together to derive some type of derivative product or merged derived product. This is not a new concept, but it's something that increasingly is something that I think you'll see being used more commonly. So with that, any questions?
Tony, this is Roger Ryder. I do have one. Can you hear me?
I can, Roger. Go for it.
Regarding communications information, when you're sharing data, what are the data requirements? As an example, language, programs, etc. Because I think that's a great concept. But I was curious, what are the limitations regarding how to share that data?
That's a good question. You know, I think part of it is, are there licensing requirements? That's the first thing to be concerned with. You know, who owns those data or that data? I think that's really important. But, you know, if it's an authoritative data source, if it's publicly available, oftentimes you just need an internet connection to get to the data, right? So sharing it is increasingly something that's just easier and easier to do. You know, these days you're not needing to take an external hard drive and ship it to someone across the country, and you know, maybe a couple of weeks later you're able to like get some answer to your question or use the data in some type of analysis. With everything in the cloud these days, that ability to share and communicate data effectively is much, much easier. But I would say data privacy and data licensing requirements are the first thing to pay attention to. First of all, can you share it? And if you can, then okay, there's a lot of good options to do that. I don't know if that answers your question, but.
Yeah, one follow-up is, are there any language or program requirements within that? And I thought your answer was great, but further on, is there any particular format you need to be able to use in order to share?
Good question. So data format, essentially.
Yes.
I think is what you're asking. You
Correct.
know, these days, you know, there's a lot of sort of standard common use formats certainly for geospatial data. Like with LiDAR, you typically will work with LAS files, and that's a very basic common data type. In terms of raster imagery, often you're sharing GeoTIFFs or maybe GeoJPEGs. So again, a very, very widely recognized and used data type or data format. So that type of thing has really become very seamless these days, where you can just grab pretty much anything and it'll be in some common standard format, and you can just pull it into pretty much any tool or application and use it.
Great. Thank you, Tony.
Sure.
I've got one other question on the chat queue there, Tony. I don't know if you can see it. Regarding satellite Wi-Fi, are there latency issues?
Yes, good question. There are latency issues, and if you noticed on the slide where I talked about satellite Wi-Fi, I believe Starlink is currently at 40 milliseconds. I'm not that familiar with what that means in practical terms, but the other two sort of key players these days with satellite Wi-Fi, they're anywhere from 25 from 50 to 500 millisecond latency times. And those other companies, their satellites have a higher Earth orbit, so they're farther away from the surface of the Earth, and that's why you have that latency. So it's just a delay in the input-output, right, from the data transfer. So it is an issue, but it's something I know they're working on, and of course that's part of the reason why Starlink is one of the leaders right now, because their data latency is much lower. So good question. And I'm sure that will evolve over time, as all technology does, right? I mean, everything that we've been talking about the past half hour, in another few years, it's going to be a different conversation, at least with some of this. Good question. Any other questions?
That's all I have in the queue, Tony. And folks, we're getting a little bit short on time. So Tony, thank you very much for your time and your information. Appreciate your willingness to talk to us today.
You bet. Thanks, everyone. And don't hesitate to reach out anytime. You've got my email there on this slide.
Yes,
Thanks
thank
again,
you.
everyone.
And everybody that's still here, please remember to send Cindy Pascal at cpascal@maine.edu an email to let her know that you were here, so she has your current information. That way we can make sure everybody gets the certificates that they need. So with that, folks, we'll end today. Stay tuned for the next couple of sessions to come in December. Have a safe and happy Thanksgiving holiday, and we'll hope to see you guys again. Take care.
Thank you.
Thanks, everyone. Thanks, Ray.
Thanks, Tony.